Let's understand this method, steady state approximation. अगर आप लोगों को याद हो, जब हमने नॉन एलिमेंट्री रिएक्शन डिस्कस किया था, वहां हमने बात की थी आरडीएस की. लाइक नॉन एलिमेंट्री रिएक्शन अकर इन मोर देन वन स्टेप, एंड आउट ऑफ दोज 2, 3, 4 वॉट एवर स्टेप्स आर देयर, वी राइट द रेट इक्वेशन ओनली फॉर आरडीएस. याद आ रहा है? सपोज जैसे आपका कोई रिएक्शन है, ए प्लस बी गिव्स सी, and if this is non-elementary, so it can have a reaction mechanism something like this. If first step is the, we can write the rate equation as KCA power A plus CB power B by 2. वो कोई प्रॉब्लम नहीं है उसमें, क्लियर है. बट इफ दिस इज द RDS, then rate equation will be R is equal to K concentration of C star power 1 plus concentration of B power B by 3, where C star is what? Intermediate product, and we don't have any control over that because we are not sending it and neither we are getting it in the outlet. So we have to change CC star in terms of CA or CB, clear, or both. So this we can do by steady state approximation as well. There are some other methods as well, but for our syllabus we have to deal with this. We have to discuss steady state approximation, also termed as pseudo steady state approximation. Clear? Suppose we have a reaction, for example, A plus B gives C and further C gives D. This is the reaction, let's say. And here if these are the reversible reactions, where D is the final desired product. K2, K3, K4, or you can write any other notation, doesn't matter. So if you try to write this separately, you can also write it as A plus B gives C, C gives A plus B, C gives B. Here this is K1, K2, K3 and K4. इस तरह से भी लिख सकते हैं, कोई प्रॉब्लम नहीं है. क्लियर है सभी को? हेलो. अब इक्विलिब्रियम का क्या मीनिंग होता है? रेट ऑफ फॉरवर्ड प्रोसेस शुड बी सेम एज रेट ऑफ बैकवर्ड प्रोसेस. जो हमारी फीड है उसमें हम क्या इंट्रोड्यूस करेंगे? व्हाट डू यू थिंक? विच कंपोनेंट्स विल बी देयर? A and B reactants. C is the intermediate product, here we can say that, and D is the desired product, and generally we don't introduce the product in the feed. Okay, so CD naught will be 0. So amount of D will be 0 initially, and whatever D is there in the reaction mixture, that is due to the formation of D. Clear? Because C is disappearing into D. Because of that हम D होगा, and amount of D will be small. So this is the disappearance we can clear है? Because reaction होने के लिए D होना भी तो चाहिए. अगर D नहीं है तो फिर reaction कैसे होगी? So we can neglect this step. So in that case your reaction will be like, actual reaction you can write like A plus B gives C, C gives A plus B, and C gives D. only this reaction mechanism will be there, which will exist, which is possible. क्लियर है? और इस रिएक्शन मैकेनिज्म में स्टेडी स्टेट अप्रोक्सीमेशन मेथड बोलता है, वो ये बोलता है कि द स्टेप इन विच प्रोडक्ट इज गेटिंग फॉर्म्ड इज द RDS. मीन्स दिस स्टेप विल बी द RDS because here product is getting formed. So what will be the rate of reaction? That will be equal to power 1. And all these are elementary steps. Clear है? Hello? तो अब इसमें हमें क्या करना है? Obviously we cannot use this rate equation directly to solve the things, to design the reactor or anything. We have to eliminate Cc in terms of, we have to write in terms of Ca or Cb or both. That is what we want. Clear है? Hello? अब वो कैसे कर सकते हैं? तो उसके लिए इन्होंने सिंपल सा लॉजिक दिया है कि दिस इज स्टेडी स्टेट अप्रोक्सीमेशन. सो द रिएक्शन विल अकर एट स्टेडी स्टेट एंड दैट मीन्स इफ यू ट्राई टू ड्रॉ अ कर्व between concentration of C versus reaction path. Actually there is no C, we are not introducing, that is the intermediate. वो कौन भेजता है? कोई नहीं भेजेगा. तो as the reaction will progress, the concentration of C will start to increase. Clear? Initially तो C है ही नहीं, कुछ नहीं है, सिर्फ फर्स्ट A plus B के तो C फॉर्म होना स्टार्ट होगा तो उसका अमाउंट इंक्रीज करेगा. And when we will have a sufficient amount of C there, then C will also start. But at that moment, the rate of formation of C, rate of disappearance of C will be same. They will be equal. They will be at steady state. So the concentration of C will be constant. At steady state, they say rate of formation of C will be equal to rate of disappearance of C. That means concentration of C will be constant during the steady state, and as the reaction will reach towards the completion, so C, what will happen? All the A and B is reacted. Now there is no A, no B, no formation of C, and formation of C is not there, so only disappearance of C will be there. So concentration of C will start to decrease, and finally we will get the desired product only, or maybe some unreacted A or B, but we will not get C because C is the intermediate product. और आपको पता है definition से intermediate products are those which form during the reaction and disappear during the reaction only. Neither we are sending them, neither we will get those in the outlet. Clear है? तो यही है बस steady state approximation. अब इससे कैसे कर सकते हैं तो देखते हैं. तो रेट ऑफ फॉर्मेशन ऑफ सी क्या होगा? K1 Ca Cb. That's it. Clear? And rate of disappearance of C? K2 Cc plus K3 Cc. Clear? So Cc will be equal to K1 Ca Cb over K2 plus K3. And when you put this value of Cc in the rate equation, you will get R is equal to K1 K3 Ca Cb over K2 plus K3. Simple. Clear?